Hello and welcome to our webinar introducing the FVA-Workbench 10. I'm very happy that you are joining us today and that we're looking together at FVA-Workbench 10 and the new features. I have an interesting agenda for you that we're going to go through today. But before we start in, I really wanted to share this feedback from one of our attendees this morning. We had the German session this morning today, and he wrote that he found it a nice presentation, especially the 2D modeler that we're going to see in just a minute. He found really cool, and even his cat approved it. So I really wanted to show you this feedback, and I hope you like it as well. If you have feedback, I really would look forward reading your feedback in after the presentation. You will see a form where we ask you for your feedback. Also, on the right-hand side in the panel, you see a questions tab. If you have any questions, please post them there. And after the presentation, we're going to go through your questions and answer them. If we don't manage to go through all the questions, I'm going to come back to you and answer them to you privately. So I would say we're starting into the presentation, and I would like to start with our 2D model. Before we start before we go into the details, how it works and how you could work with it, we need to answer the questions why we should care about a new model. Modeling in the FVA Workbench is quite powerful. However, as you might know, you have a global coordinate system, and there's a shaft coordinate system where you're locating the bearings and the loads and also the shaft sections. So you already have two different coordinate systems that you need to take care of. Then, as we're looking at the planetary stage here, the side plates here look really weak, and it's really hard to detect those modeling errors or the proportions in a 3D view. And also I would like to draw your attention to the bearing here. So here we have an intersection of the bearing and the gear that we didn't see in 3D, and now in a 2D view we can really spot those modeling errors. So let's discuss the functionality of such a 2D modeler. Here we have a bevel stage, so not all shafts are in parallel. And in order to work with such a system, it might be comfortable to rotate the view so that you have the shaft that you're working with in a horizontal alignment. And this works even with arrangements where it's not exactly 90 degrees. So even very complicated gearbox designs are easy to work with a rotate view. We have two snapping modes to work with. The default snapping mode is the component snap. So if you would like to go through or to move a bearing, for example, or a gear, you will see that towards the ends of a section of a shaft, the component is drawn towards the ends and wants to stay there, and that's the component snap. However, in some occasions, it might be beneficial to change to the grid snap, especially when working with shafts. That facilitates inputting the correct distances and diameters. On the left-hand side, you can see a model tree, and with those checkboxes, you can hide and show the components. So especially if you have systems where components are overlapping, you can show and hide them to facilitate working with the model. Below the component tree, there are some customization options for the projection. We really worked hard on getting a very good default. However, in some cases, it might be beneficial to compact the view or widen the projection a little bit. And I would like to invite you to try to work with the projection a little bit and find a projection that works for you. On the right-hand side, there is a component property view, and you can access it by just clicking on the component. In this case, I have a bearing selected, and in this component editor, you can select a new bearing or change the force absorption, the axial force absorption. So if you want to change the bearings from a non-locating bearing to a tapered roller bearing setting, like in this case, you can do that directly from the 2D model and don't have to change the views. You have it all in one place. However, one of my absolute favorites of this release is the relative component positioning. In the past, the position of a component on a shaft was given in a shaft coordinate system, and if you changed the shaft, the position of those components were not updated. And with the position reference, the relative component positioning, it's quite easy to position it. And as you can see here in the video, it also changes if you move this, if you change the shafts. That makes it very easy to modify your shafts and your whole gearbox. So to summarize the benefits of such a system, it helps you easily and quickly set up a new model, and it makes it very easy to generate shafts from a drawing. We haven't seen that yet. However, we're going to show it in just a minute in a quick demonstration. It's very easy to identify modeling errors, and it's very simple to adjust the model with the relative positions. And also, we think that this is a very good addition to the FVA-Workbench. It makes working with it so much more easy. So we decided to give this feature to everybody as a free upgrade for all licenses. We would be very happy if you test this feature, and since we're going to update it in the coming updates, we're going to work on this feature in the next iteration. We're really looking forward to your feedback, and if you would like to have something changed, or if you're missing a feature, please contact us via our support system, and we're looking forward to your feedback there. The next addition, before we jump into the FVA-Workbench, is a customer feedback we've got quite often, where they said, okay, FVA-Workbench is too slow. And honestly speaking, we didn't understand the feedback, because benchmarks showed that the FVA-Workbench is faster than other tools, in some cases quite significantly though. So we looked into this feedback, and we realized that it's not the pure calculation time. It's the report that's taking time, generating the report and evaluating the report. So we decided to break down the reports into smaller chunks and put them into a quick result view. The quick result view can be found here in the top right-hand corner, and you can decide what you want to see. So in the quick report view, you can display all current results, and you can select what you would like to see. In this case, we have an overview over the efficiency. But you can change the component that you would like to evaluate by just selecting a component in the model tree. And on the top right-hand corner, you can change the results that you're seeing for the component. So if you would like to go into deeper details for load capacity, well, the results are there. If you would like to dive deep into the efficiency, all the results are there in small digestible chunks. One information that's quite important is here on the bottom line, there's a quick indicator that the result is valid or invalid. So normally, if you see a result, you want to modify the gearbox to optimize it. And if you change the model based on the results, here it's going to inform you that the results are not matching exactly the model, so that you're going to be aware that you changed something. I think the benefits of such a quick result view are quite obvious, and it allows you to quickly access the results and allows you to work more efficiently with the results. You don't have to generate the report quite as often, and you have it in small digestible chunks. It's still a very attractive presentation, and it simplifies the evaluation of your gearbox and making changes to your gearbox so that you can work quite efficiently. It's quite instant. You get the results instantaneously, and you don't have to wait for the report generation. Especially for larger models, this can take quite some time. And also, this feature is going to be a free upgrade for every license, because we really think this brings the FVA-Workbench forward and helps you in your daily work. And now I would like to demonstrate those features to you directly. And for that, I would like to start in an empty model in the FVA-Workbench. To generate a model, I would like to start with the preliminary gear design. We start with a torque of 100 Newton meter and 1,500 rotations per second, with a gear ratio of about 3. Here we can check the gear geometry, change a little bit of the geometry if we would like to optimize it. However, I just want to use it to generate a model quickly. And here we can see it. So basically we are done. However, I would like to, I don't like the shaft design, so let's change it. In order to change the shaft design, I select the shaft as a component in the component properties, we can see the button here, Edit Shaft Contour. And in the shaft contour editor, here we can see the image button. And with the image button, I can load a shaft drawing. From there, I can load a drawing as an image or a PDF. And then I have to select the center line and give the editor the length of my shaft. So it is given here by 280 3 millimeters. Now I get the shaft drawing as a as an image in the background. Now I can position the nodes here on the line, on the lines of my shaft drawing. You can see it's quite fast to position it step by step, point by point. Also, here you can see a quick information with the distances and between the adjacent points. This helps you to model the system. In such a case, or in this case, you can see that we see a red dashed line. This informs you that this is not a valid geometry for a FVA workbench shaft. If we would like to model a recess, we need to model a notch, in a shaft notch. And this red dashed line informs you that this is an invalid geometry. Okay, so I'm missing 1, 2, 3, 4 more points, and with the button here I can add them. So as you can see, this is quite fast in modeling a new shaft. And here you can see that if we select a node, it's not exactly the diameter 32. So in this case, I select the snap to grid option, and now it allows me to just change it quite easily. Okay. So now we need to position the bearings to the right location. I'd like to have them here and there, and we need to position the gears. In this case, I would like to draw your attention to the position reference. And here we can align the gear towards the left-hand side of the shaft. And also we can align the bearings with the left-hand side shoulder and also the right-hand side shoulder towards the shaft. This helps us if we later want to modify the geometry like this. You can see that the bearing is following the shaft shoulder. And with selecting the bearing, we can in the component property view select a new bearing. In this case, I would like to have a deep groove ball bearing, and from we can select a deep groove ball bearing, and I would like to select this one. On the other hand, on the other side, I would like to have a cylindrical roller bearing, and I'm selecting this type. You can see it's quite easy. Now we need to align the gears as well, and we can do this by selecting the shaft and adjust every component on the shaft along the axis. And this is how you can quickly and efficiently change the model of your gearbox and change the components like the bearings. Adjust the model and then run the simulation. And here you can see at the top right-hand side the quick result view, and by changing the components, here you can see how the quick result view is changing. And here you can select, for example, the geometry and get all the information about the geometry of your gears and the tools that you're using. Okay, let's go back to the presentation, and I would like to go towards the variant generator. So in the past, we excuse me. In the past, we had a couple of ways to modify the gearbox model. You could adjust it manually. You can run scripts to adjust the model for you, or with the new variant generator, you can generate the variants with a nice GUI. It's not restricted to a component. It works on the systems level. So as a basis is the system simulation. And you can change the model quite fast and efficiently. That allows you to run some variant calculation quite efficiently, and afterwards analyze the results in the analyzer. You can find the variation, or you can configure your variation at the top right hand side at this button. The analyzer is right beside it, and you can see that the model snapshots are grouped together so that you can see at first glance that this is a variation. All snapshots in this list are full models, so you can store them in the model, save them as a model snapshot, and work with them later on. So they have a full functionality here. So let's make an example. This is a basic model from our easy entry view, and I wanted to change the the actual force absorption of the input shaft. The first shaft is set as to positive, negative. Then we have a force absorption on the left-hand side and on the right-hand side, and both sides as well. And I did it in such a way that I searched for the attributes here in the search bar. We have some component filters so that you can filter the component as well, makes it more easy to find your attributes. And from the list, you can select the attributes that you're looking for. Here you can define the number of variants, and I didn't put it into the slides, but here's also a calculation mode. Currently, the variations are defined line by line, so each line is one variant. However, in some cases, it's more appropriate to vary every cell with every other cell, and you can switch it here. So here you find a full factorial. And here at the list, at the bottom, you then define the attributes of the variation. You can run the variance, or calculate the variations here with the button, Run Simulation, and then you will see this screen where you get the list of all the calculations, and the color indicates you if the calculation was successful or not successful. Especially if you have huge calculations, this is quite helpful to see how many calculations were successful or not. After the simulation, you can go into the analysis, and it's set up quite similarly. So you can find at the can find at the top a save or load configuration. So if you want to repeat a variation analysis that you've done before with another model, you can load this analysis, and it loads the attributes and tries to match also the component IDs wherever possible. It also loads the diagrams that you've set up, and that helps you to quickly analyze your variations. Again, you can search the attributes with the search bar and filter it with the available filters. You can select the attributes from the list and select the snapshots that you would like to evaluate here on the left-hand side. In the list here, you can select the components from the model, and here you can see also an overview over the results if you would like to see the numerical values. You can then set up the diagrams, and they look something like this. For example, you have an XY diagram. Here you can see, for example, for our example, the phase load factor over an ascending X coordinate, or we can see the phase load distribution over the width of the gear, or for example, the changes in bearing life that our changes in the location or the actual force absorption of our bearing has. So we can see that in this case, it has quite a dramatic impact on the bearing service life, which is to be expected. The benefits for such a system is you can quickly set up variants and vary the attributes for any component. So this also allows you to vary, for example, a complex predefined planetary gearbox. You can optimize a bearing arrangement. You can optimize a preload arrangement on the bearing. You can quickly find optimal solutions. You don't need to script for it, and you get detailed insights in your system simulation. And I really would like to show it to you in a live demonstration. For that, I loaded the model that we've seen in the slides, and here we can see how to generate the variance. So this is the view, and it's quite easy to filter for the components. So I can look for the center distance, and I could load the center distance into my variation. But here I would like to look at the actual force absorption. I already pre-configured it, so we don't have to waste the time in the configuration. And here I can run the simulation. So the simulation is done, and we can close this view and open the analyzer. Here you can see I already loaded up a configuration. We can see that we have the phase load distribution and the coordinates for the phase load distribution in our analyzer. We have the phase load factor and the bearing service life. In order to load the diagrams, I select the diagram type and bring it into view. It's quite easy to configure it. You can see that it's just a drop-down menu from the attributes that you loaded into the variation. You can change it to quite easily. So in this case here, you can have an array attribute that you can compare. For example, if you would like to compare a transmission error for different gearbox variations, or the phase load distribution, or other arrays in the FVA-Workbench, which is quite handy. So this is how the analysis is set up. With this dropdown, you can change the type of of the diagram. For example, if you'd like to see a bubble diagram, or if you would like to see a XY diagram. It's up to you. Okay. Our customers reported back to us that they are increasingly using more modern methods and processes for gear production, like, for example, a power skiving process. And well, I don't think I need to convince you of the benefits of such a cutting process. But for us, it's important to also provide you with the tools to calculate such a process if you would like to use it. And we're planning to do it in a two-stage process. With the FVA-Workbench 10, we're going to look especially at the target geometry. The target geometry is defined by the tip diameter, the root diameter, and the root fillet radius. In this instance, we're going to assume that the root fillet is a circular segment. We know that this is not true. But with the FVA-Workbench 10.1, we're going to release the actual geometry that is generated by the tool geometry. And this allows us then to compare the current and the actual geometry with the target geometry by comparing the profile curve, and also have derive a FH beta from those geometries, which I think is quite interesting. So let's have a look how it's done today. Currently, you can change the profile generation to by skiving. Beforehand, we had by hobbing tools, or injection molding, or by tooth geometry, and now you get the option by skiving. By enabling this method, you need to input the tip diameter. If you have a chamfer at the tip, you can edit this as well. And also you need to input the root diameter and the root fillet radius. This is also, as everything what we're doing, it's also based on FVA research, the Research Association for Drivetrain Technology, which makes sure that the results are of highest quality. And we think this is quite an important step, and allows you evaluate the geometries for modern processes. So this is why we wanted to add this as a free upgrade for all licenses, and we would like to invite you to check it out and give us feedback if you have feedback on it. We would be happy to incorporate your feedback with this feature. The next feature is, honestly speaking, one of my personal favorites. At the International Conference on Gears 2 years ago, we presented the idea that the pitting load capacity calculation for bevel gears might be applicable for cylindrical gears as well. And the results were quite promising back then. And due to frequent customer feedback, we incorporated this load capacity rating. The problem with ISO 6336 load capacity is that it only evaluates one point. And you need to trust that this one point is representative for the whole flank. This is mostly correct, but there are some cases where it's probably insufficient. And by looking at the whole flank as a matrix, you would be able to include additional parameters like curvature radii or the specific sliding, which are currently not, or just only representatively included into ISO 6336. And then there's also the question: how do you rate a pressure distribution or the sliding of a gear? And with this FVA-based method, you have a coherent methodology of rating your pressure distribution together with the sliding and all the other influencing factors that go into ISO 6336. And I made a comparison. I posted this recently on social media, where I changed the addendum modification for this gear geometry here. And you can see by changing the addendum modification, the specific sliding moves toward the left and decrease, or the negative specific sliding decreases. And also, this is probably the main influencing factor with negative addendum modification coefficients. You have smaller radii of curvature in the foot root area of your contact, and that is increasing the pressure at the flank locally, which means the safety factors are decreasing, and you can see that on the top left-hand side here. What I found very interesting, but in conducting this comparison, is that overall the ISO 6336 rating is about constant, whereas the minimum safety factor of FVA 411 safety factor is increasing rapidly with my by increasing the addendum modification coefficient. I think the benefits for such a method are quite obvious. You would be able to consider more parameters than ISO 6336, and by that you can have a result for the whole flank, not only one representative value. During the beta test of this version 10, we discussed it with selected customers, and they explained to us that it's quite interesting that they found with that method hidden performance reserves of their gears. And with this calculation, they might be able to argue to load them even more. One customer told us that they compared it with test bench results, and they were quite striking, which is very informative, I think. So this allows you to get a more detailed view into your system and also your gearbox design. Since this is my personal favorite feature, I would like to show it to you as well. So I close down the comparison that we did before. I'm going to use this model again, and it's quite easy to set up the load carrying capacity. You just select this checkbox, local pitting safety according to FVA 411, and then you run the simulation. It's, as I said, it's mostly the ISO 6336, but also the radii, the curvature of the flank, and also the sliding. So there's nothing much to edit here. And here with our quick result view, can select the local pitting load capacity. Here you can see the influencing factors that went into the calculation as a table. And here we have our safety factor as a diagram over the flank. I didn't include it into my presentation, but we also modified the ISO 6336 part 22, which is the micro pitting load capacity rating, according to the latest research from FVA-516. This was a research conducted on bevel gears, but we looked into it and we think that it might be beneficial for cylindrical gears as well. So I would like to invite you to check out this new feature and try it for yourself. If this adds something, or it allows you to get better results than the pure ISO rating. In order to configure the micro pitting calculation, you need to select the cylindrical gear stage, and here on the lubricant tab at the bottom here you can find all the input variables, and here you can also extend the factors according to FVA 516. Yeah. Okay, let's go ahead and look at the additional features that we included with FVA-Workbench 10. As you might know, in the past we changed that we only incorporate housings as a single solid. Now you can import housings that are multiple parts, and then you need to define the contact between those parts. And it used to be quite cumbersome, and you needed to open the dialog for every contact you wanted to define, and we changed that with this update. So you open the dialog only once, and you can add a new contact with the button here. After that, you can define the contact partners, and here you can find a list of all contacts. So if you have a housing with multiple parts, you need to connect all the parts together so they don't fly away when loaded. And here you can see then the list of all contacts that you already defined. Below the list, you can see that you you can define the contact as a plane, but you can also define it as a cylinder. So if you would like to combine cylindrical parts together, that's now possible as well. And the contact area is also defined by 3 points, and then you apply the contact area. And yeah, we also integrated REX 1.7, the latest REX standard. As you might be aware, the REX standard helps you to connect tools together in a standardized format. Most of gear design tools are supporting the REX standard as an import and export format, and it helps you to set up integrated processes. And with the latest release, we focused more on the tool chain. We added different tools to help you set up integrated processes. For example, a validation tool that validates if the exported REX file is according to standard, or a comparison tool that you could compare two REX files and help you figure out if those are the same models. That helps validate a tool chain with multiple tools. And also, sometimes you have the issue that one tool is only supporting REX 1.7, and the other tool is only supporting a lower version. You need to connect it anyway, and with the we have a tool also for that downgrades version or upgrades version of the REX format, and that helps you connect tools that do not support the same version of REX. Some customers also mentioned to us that PDF exports are quite important for them, and this is why we we changed the export to PDF. In the past, it wasn't quite as nice as it used to be, or as it is now. And we used to have a blank page at the beginning, and we got rid of that in the end. So now it's much improved, and I would encourage you to use the PDF export as well. Towards the end, I really would like to mention our conference lineup. As you might know, we also have conferences, and I would like to invite you to check them out. Here we have a QR code that brings you to our homepage, and there you can find our upcoming conferences. The next conference is in Aachen, Germany. It's the conference for wind power drives and drivetrain systems engineering. It's quite a big conference, and I will be there personally and presenting the FVA-Workbench, and I'm really looking forward to meet you there. If you have questions, please come to our booth, and we can discuss the latest version in Aachen. We're going to present a new conference on digitalization of fluids and fluid systems with a Fluid X conference in Schweinfurt, Germany in September. And as every year, we're going to be in Aachen for a gear production conference. In this case, it's the Aachen Forum on Gear Production in November. The Bearing World is going to be hosted next year in Dresden, Germany, international conference on bearing technology, and I really would like to see you there. This is an awesome conference with lots of insights into bearing technology. We also have a seminar portfolio that I would really would like to show you. Those are seminars by experts on gearbox vibration and noise behavior, on load spectra analysis, on component life simulation, strength assessments, and I really encourage you to look at the seminar portfolio, because I think if you would like to improve your products, it's going to need to, or it helps if you improve your skill set first. Then I would like to mention our newsletter. With our newsletter, we're going to bring you monthly information on white papers and success stories that we are going to write with customers. We're going to inform you about seminars and webinars like today. If you would like to get to know what is going to be in the next versions of FVA-Workbench, I'm going to encourage you to sign up for our free newsletter. Also, you will get conference announcements as soon as we have them. And if you really want to participate, or you also get the call for papers for the conferences. So I really would encourage you to check out the newsletter. It's free and it's monthly, so it's not a huge spam for that. Finally, I really would like to get you the opportunity to download the slides. I've seen that they are ready now. Go download the slides if you want to have them. And this would be my presentation. I thank you very much for your attendance and your time today. I'm going to post about FVA-Workbench quite regularly on LinkedIn. And if you don't want to miss that, more insights and more case studies with FVA-Workbench, I would like to encourage you to follow me on LinkedIn. You can do that by checking out this QR code. This brings you directly to my LinkedIn profile, where you could follow me and get to learn more about FVA-Workbench. So this would be it, and I really look forward to your questions. The first question is on the 2D modeler. Will it read models created in older versions? Yes, it does. You probably need to check the components if they are located correctly and if they have the references set correctly. This is one thing I would advise you to check out. However, it loads it right out of the box. You don't have to change anything. The quick result viewer, can it show results for different runs or only the current run? No, it only shows the current run. If you would like to compare different results, we do have the compare feature that you can find in the context menu in the model snapshot viewer. There you can select 2 snapshots and select one as a reference and the second one to compare to the reference. And then you get a whole comparison of a comparison report. So this does only work with the reports. So this would be it for the FVA-Workbench presentation. If you have additional questions, please go ahead and send them to me via email. I really would like to see you on our social media, and I really would encourage you to follow our newsletter. And in the end, I really hope you like the new FVA-Workbench 10, and hope to hear from you and your feedback soon. Wish you a pleasant weekend. and a nice day. Bye bye.